Imagine standing in front of a massive painting. Bright reds, soft whites, calm orange swirls. It looks peaceful. It looks stable. It looks safe. Now, imagine stepping closer and realizing the paint is moving. The colors aren't calm, they're screaming. The shapes aren't beautiful, they're violent. And the peaceful giant you were looking at isn't a guardian at all. It's a monster. For decades, we believed Jupiter was the protector of the solar system. A giant shield that swallowed asteroids and kept Earth safe. A boring ball of gas. Stable, predictable, understood. That story was wrong. NASA just sent a spacecraft closer to Jupiter than any machine in human history has ever dared to go. Not around it. Not past it. Straight over its poles. Straight into danger. And what it found underneath the clouds wasn't gas. It wasn't calm, and it definitely wasn't what we learned in school. Jupiter is unstable. It's violent. It's breaking its own rules. The planet is throwing toxic hail into itself. Its storms are arranged in impossible geometric shapes. Its magnetic heart is cracked and drifting, and its core looks like it survived a catastrophic cosmic collision. Something is happening on Jupiter right now. Something scientists are still struggling to explain. And once you see what's really going on beneath those clouds, you'll never look at the largest planet in our solar system the same way again. Because to uncover this truth, NASA had to send a probe on what many scientists quietly called a suicide mission. For a long time, Jupiter scared us. Not in a poetic way. In a very real, very technical way. Every time humanity sent a spacecraft toward Jupiter, engineers made the same decision: keep your distance. Voyager did it. Galileo did it. Even Cassini stayed cautious. Because Jupiter isn't just big, it's radioactive. Surrounding the planet is the most violent radiation environment in the entire solar system. Its magnetic field traps charged particles and accelerates them to lethal speeds. Fly too close, and your electronics don't slowly fail. They get cooked. Instantly. Sending a probe near Jupiter is like throwing a smartphone into a microwave and turning it on full power. So for decades, we avoided the risk. Until NASA made a very different choice. In 2011, they launched a mission designed not to orbit safely, but to dive straight into danger. They named it Juno. Juno isn't elegant. It isn't fragile. It's a tank. Its most important computer systems are locked inside a massive titanium vault, nearly half a ton of solid metal, built for one reason only: to survive Jupiter's radiation long enough to send data back to Earth. But the real insanity wasn't the armor. It was the flight path. Instead of circling Jupiter like previous missions, Juno performs what scientists call polar death dives. It screams over the North Pole at over 100,000 miles per hour, drops closer to the cloud tops than any spacecraft in history, then rockets back out over the South Pole before the radiation can finish it off. Every pass is a gamble. One mistake, one unexpected surge, and the mission is over. And yet, Juno has done this over and over again, each time surviving just long enough to whisper its discoveries back across hundreds of millions of miles of space. And the very first thing Juno realized, once it looked beneath Jupiter's colorful clouds, was deeply unsettling. Those clouds aren't peaceful. They aren't soft. They aren't decorative. They're the lid on a planetary blender. And once Juno lifted that lid, scientists understood something terrifying. Jupiter isn't a calm gas giant at all. It's a bottomless machine. And if anything ever fell into it, it would never stop falling. On Earth, falling has an ending. You hit the ground. You stop. On Jupiter, there is no ground. There is no surface. There is no moment where the fall ends. If you were somehow dropped into Jupiter wearing an indestructible suit, you wouldn't crash. You would descend. Forever. At first, it wouldn't feel that strange. You'd pass through pale white clouds made of ammonia ice. The temperature would be brutal, colder than minus 150 degrees, freezing enough to kill instantly. But then things begin to change. As you fall deeper, the air stops feeling like air. The atmosphere thickens. The pressure starts stacking on your body from every direction. What was once gas becomes fog, then mist, then something closer to a boiling soup. This is where Jupiter stops making sense. You don't splash into an ocean. There's no clear boundary. Instead, the gas becomes so dense and so compressed that it turns into something called a supercritical fluid. It's a state of matter that doesn't behave like a gas or a liquid. It's both at the same time. You wouldn't know if you were swimming or flying. There's no surface tension, no bubbles, just crushing heat and endless darkness pressing in from every direction. And it keeps getting worse. Roughly 10,000 miles down, the pressure becomes so extreme that hydrogen, the lightest element in the universe, breaks. Not chemically, physically. The hydrogen stops acting like gas. But it doesn't become rock either. It becomes liquid metallic hydrogen. This is a form of matter that barely exists naturally anywhere else. A dense, flowing ocean of liquid metal. It conducts electricity. It glows faintly. It moves like a stormy sea, except the sea itself is metal. There is no solid crust here, no place to stand, just a boiling, spinning ocean of metallic hydrogen wrapped around the planet's core. This ocean is the heart of Jupiter. It's what generates the most powerful magnetic field in the solar system. It's what turns the planet into a massive electrical engine, which means Jupiter isn't just a gas giant. It's essentially a planet-sized drop of liquid metal held together by gravity. So when we talk about storms on Jupiter, we're not talking about wind blowing over land. We're talking about violent currents moving through a bottomless ocean of gas and metal. And the weather inside that ocean is beyond lethal. Because once Juno started watching the storms up close, it discovered something that shouldn't exist at all. Lightning, made of poison. Lightning on Earth is simple. It forms inside water clouds. Warm air rises, cold air sinks, charges separate. A flash follows. Jupiter broke that rule. When Juno began scanning the upper atmosphere, it detected lightning in places where lightning should be impossible. Way too high, way too cold. Regions where liquid water cannot exist at all. At first, scientists thought the instruments were wrong. Then they realized something far worse. The lightning wasn't coming from water clouds. It was coming from ammonia. High above Jupiter's visible clouds is an invisible layer of ammonia gas. Normally, it just floats there, frozen and quiet. But when powerful storms rise from deeper layers, they drag water upward into that ammonia zone. And ammonia does something terrifying. It acts like antifreeze. The ammonia melts the ice, creating a freezing slush made of water and ammonia mixed together. Not liquid, not solid, something in between. That slush begins to clump. As it falls, the outside freezes while the inside stays wet and toxic. Layer by layer, it grows. NASA gave these things a name that sounds harmless, almost cute, mushballs. But there is nothing harmless about them. Picture a hailstone the size of a baseball. Now imagine it's made of toxic sludge wrapped in ice. And imagine it falling at hundreds of miles per hour through Jupiter's atmosphere. These mushballs don't melt quickly. They get heavier. They fall deeper, hundreds of miles down. As they descend, they drag ammonia out of the upper atmosphere and dump it into the depths of the planet. Jupiter is literally throwing chunks of its own atmosphere into itself. This is why parts of Jupiter look patchy and depleted. The planet is self-stripping. And that impossible lightning Juno detected? It sparks as these mushballs collide, break apart, and smash through cloud layers below. It's a never-ending storm of poisonous hail. No seasons. No cycles. No calm period. Just toxic ice raining downward for centuries at a time. But as violent as this sounds, it still wasn't the most shocking discovery Juno made. Because when scientists finally measured how deep Jupiter's famous stripes really go, they realized the storms weren't just weather. They were part of the planet's structure, and they reached deeper than the distance across entire continents. For over 400 years, humans have stared at Jupiter through telescopes and seen the same thing. Beautiful bands of white, orange, and brown wrapping perfectly around the planet. We gave them names: belts for the dark ones, zones for the bright ones. And for centuries, we were confident about one thing. Those stripes were shallow, just clouds. A thin layer of weather sitting on top of a gas giant, maybe a few dozen miles deep. Nothing serious. Juno destroyed that idea. Instead of just looking at the clouds, Juno measured Jupiter's gravity with extreme precision. It watched how the planet tugged on the spacecraft during each close pass. And from those tiny changes, scientists were able to weigh the winds themselves. What they found was staggering. Those stripes don't stop near the surface. They plunge deep into the planet, thousands of kilometers deep, deeper than the distance from New York to Los Angeles, deeper than Earth's crust, deeper than anything we expected atmospheric winds to survive. These aren't clouds painted on the outside of Jupiter. They are massive, rotating cylinders of gas that extend far into the planet's interior. Imagine stacking enormous spinning rings inside each other, each rotating at a slightly different speed. Now imagine all of them grinding against one another endlessly. That's Jupiter. The entire planet is built from motion. If you could somehow press your ear against Jupiter, you wouldn't hear silence. You'd hear a low, constant vibration. A deep humming sound made by billions of tons of atmosphere sliding, rubbing, and tearing past itself. A planetary heartbeat made of wind. And here's where it gets even stranger. Those deep winds don't just go on forever. Eventually, they slam into something. At the bottom of these massive jet streams, the gas transitions into liquid metallic hydrogen. And that metallic layer doesn't behave like air at all. It acts like a magnetic wall. The winds crash into it and stop. The energy has nowhere to go, so it churns upward, feeding storms near the surface again and again. This means Jupiter's weather isn't separate from the planet. It is the planet. The storms aren't happening on top of Jupiter. They are happening inside it. Jupiter isn't a ball of gas with weather on the outside. It's a fluid machine, with moving parts thousands of miles thick, and once Juno reached the poles, scientists expected that machine to look chaotic. They were wrong. What they saw there shouldn't exist at all. Nature hates symmetry. Rivers curve. Clouds scatter. Storms collide, merge, and collapse. So when Juno flew over Jupiter's North Pole for the very first time, scientists expected chaos. A violent swirl of storms fighting for dominance. A boiling mess of clouds with no order. That's not what they saw. At the exact center of the North Pole sat a massive cyclone. One storm, roughly the size of the United States, spinning relentlessly in place. But that wasn't the shocking part. Surrounding it were 8 more cyclones. Perfectly spaced. Perfectly balanced. Arranged in a flawless octagon. Each storm is thousands of miles wide. Each one spins in the same direction. They push against one another, grinding at their edges. Yet they never merge. On Earth, storms don't behave like this. When hurricanes collide, one absorbs the other. Order collapses into chaos. On Jupiter, these storms are locked in place. They bump. They grind. They threaten to collide. But they stay in their lanes, as if something invisible is holding them there. And when Juno flew over the South Pole, things got even stranger. There was another central cyclone, but this time it was surrounded by 5 storms. A perfect pentagon. Why 8 storms in the north and 5 in the south? No one knows. According to everything we understand about fluid dynamics, this setup shouldn't be stable. It shouldn't last. It shouldn't even form. It's like stirring a cup of coffee and watching the foam arrange itself into a perfect geometric shape and then stay that way for years. These crystal-like storm patterns suggest something deep inside Jupiter is guiding them. Something powerful. Something structured. Almost like the storms are attached to invisible rails buried beneath the clouds. And those rails lead directly to the most violent force Jupiter has. A force so strong it warps space around the planet. Its magnetic heart. Jupiter doesn't just have a magnetic field. It has the strongest magnetic field of any planet in the solar system. 20,000 times more powerful than Earth's. If you could see it with your eyes, it would stretch so wide across space that it would look bigger than the moon in our night sky. Normally, magnetic fields are simple. They come from deep inside a planet's core. They have a North Pole and a South Pole. Clean, symmetrical, predictable. Jupiter ignored that rule. When Juno began mapping Jupiter's magnetism in detail, the data came back wrong. Not slightly off. Completely broken. The strongest magnetic signals weren't coming from the core at all. They were coming from a strange, concentrated region near the equator. An invisible scar. Scientists nicknamed it the Great Blue Spot. It isn't a cloud. It isn't a storm. It's a magnetic bruise, a region where Jupiter's magnetic field is violently compressed and distorted. Even stranger, it behaves like a second South Pole. Not where a pole should be, but sticking out of the planet's side. And then Juno noticed something that made the situation far more unsettling. The blue spot is moving. With every pass, Juno tracked it drifting eastward. Stretching. Warping. Being pulled apart by the deep winds below the clouds. This was a massive clue. On Earth, our magnetic field is generated deep in the core, far away from surface winds. But on Jupiter, The magnetic generator sits much closer to the outer layers. That metallic hydrogen ocean we talked about earlier? It isn't calm. It's flowing, churning, sliding in massive currents. Jupiter is acting like a planet-sized electric dynamo that's starting to lose stability. The magnetic field is being dragged, twisted, and torn by the planet's own motion. The Great Blue Spot isn't just strange. It's evidence that Jupiter's interior is shifting in real time. And that magnetic chaos doesn't stay hidden. It creates something above the planet so extreme, so violent, that it doesn't just glow. It screams. On Earth, auroras are gentle. Soft curtains of light dancing silently across the sky. Beautiful, calm, harmless. Jupiter's auroras are none of those things. When scientists first observed them closely, they realized something was very wrong. Jupiter's auroras don't just glow, they pulse. Every 27 minutes, like clockwork, the planet unleashes a massive burst of energy into space. Not visible light, X-rays, radiation powerful enough to light up detectors millions of miles away. For years, no one understood where this energy was coming from. The solar wind wasn't strong enough. The math didn't work. Then Juno found the answer. And it wasn't the sun day. It was one of Jupiter's moons. Io. Io is the most volcanic world in the entire solar system. Its surface is constantly tearing itself apart, erupting non-stop, spraying sulfur and gas into space every second. That material doesn't drift away. It gets trapped. Jupiter's magnetic field grabs it, accelerates it, and turns it into superheated plasma. This plasma forms a massive invisible ring around the planet. But that's only part of the story. There is an invisible electrical bridge connecting Io directly to Jupiter's poles. A constant flow of current, millions of amps, never shutting off. It's like a giant lightning bolt stretched across space. That electrical current slams plasma straight into Jupiter's upper atmosphere. Over and over again. Every 27 minutes, the system discharges. The result is an aurora so violent it screams in radio waves. Juno recorded the sound. It doesn't sound natural. It doesn't sound mechanical. It sounds like something alive. A planet shouting into the void. Jupiter is literally electrocuting itself using material ripped from its own moon. But as terrifying as that sounds, it still wasn't the most disturbing discovery Juno made. Because when scientists finally mapped Jupiter's interior, they realized the planet doesn't just behave like a monster. It was forged by one. Before Juno arrived, Jupiter made sense. At least on paper. Scientists believed the planet was layered and orderly. Clouds on the outside, a thick envelope of gas beneath them, an ocean of metallic hydrogen deeper still, and at the very center, a solid core made of rock and ice. Simple, elegant, predictable. Juno tore that picture apart. As the spacecraft flew past Jupiter again and again, it measured tiny changes in gravity. Minute tugs so small they were almost invisible. But when scientists mapped those tugs, the results were impossible to ignore. There was no solid core, no hard center, no clean boundary. Instead, Jupiter's core was fuzzy, diffuse, smeared out. Scientists call it a dilute core, but that phrase doesn't capture how wrong it feels. Imagine taking a peach and throwing it into a blender. The pit doesn't stay intact. It shatters and mixes into the fruit. That's what Jupiter's core looks like. Rock, ice, metallic hydrogen, all mixed together into a chaotic soup that stretches across nearly half the planet's radius. This should not happen. Gravity should have pulled the heaviest material straight to the center and locked it there. Something had to disrupt that process. Something violent enough to stir the entire planet. And there's only one thing capable of doing that: a collision. Not with an asteroid, not with a comet, with another planet. The leading theory is that billions of years ago, when Jupiter was still forming, a protoplanet, roughly 10 times the mass of Earth, slammed straight into it. A head-on impact. The collision was so powerful, it shattered Jupiter's original solid core and mixed it into the surrounding layers. The planet absorbed its victim completely. Jupiter didn't just grow large. It ate another world. And the evidence of that ancient act of cannibalism is still floating inside it today, refusing to settle. The core never healed. The planet never stabilized. Jupiter is still digesting a planet it consumed more than 4 billion years ago, and that instability doesn't stay hidden inside. You can see it on Jupiter's face. Because even the planet's most famous feature is starting to fail. For more than 300 years, one feature has defined Jupiter more than anything else. A massive red storm. A swirling eye. A symbol of permanence. The Great Red Spot. It has been raging since before the American Revolution. A storm so large that Earth could once fit inside it multiple times over. For generations, astronomers believed it was eternal. It isn't. When scientists compared old observations to modern images, something unsettling became clear. The Great Red Spot is shrinking. In the late 1800s, it stretched nearly 25,000 miles across, wide enough to swallow 3 Earths side by side. Today, it's barely 10,000 miles wide. It's losing mass. It's becoming rounder, taller, more compact. And then something even stranger started happening. Amateur astronomers noticed red streaks peeling off the storm's edges, long blades of gas tearing away and spinning into the surrounding atmosphere before fading out. The storm wasn't just shrinking, it was shedding itself. When Juno flew directly over the Great Red Spot, it used microwave instruments to peer beneath the clouds. What it found surprised everyone. The storm's roots run deep, over 200 miles down into the planet, deeper than Earth's oceans. The Great Red Spot isn't just a surface feature. It's a massive heat engine, pulling energy from Jupiter's interior and pumping it upward into the atmosphere. But even with that depth, the storm is losing the fight. The surrounding jet streams are tightening. The winds around it are speeding up. The center of the storm is growing calmer, a sign of decay rather than strength. Some models suggest that within the next 20 to 50 years, the Great Red Spot could disappear entirely. Imagine pointing a telescope at Jupiter and seeing nothing but stripes. No red eye, no ancient storm, just blank bands where one of the solar system's most iconic features used to be. It's a reminder that Jupiter isn't a frozen snapshot of the past. It's alive, evolving, and slowly changing before our eyes. And while one ancient storm fades, Jupiter's influence continues to spread outward. Because its violence doesn't stop at its clouds. It reaches its moons. Jupiter doesn't exist alone. It rules an entire system of moons, and it treats them brutally. Jupiter's gravity is so powerful that it constantly stretches and squeezes the worlds orbiting it. Not gently, violently. This endless flexing creates heat. On the moon Io, that heat turns the surface into chaos. Io is the most volcanic place in the entire solar system. Its ground is ripped apart again and again, erupting non-stop, flipping its surface inside out every few days. It isn't cooling down. It isn't stabilizing. Jupiter won't let it. Io exists in a constant state of destruction because the giant planet keeps crushing it like a stress ball. But one moon tells a very different story. Europa. At first glance, Europa looks dead. A smooth shell of ice. Cracked. Frozen. Silent. Juno changed that picture. During close flybys, Juno sent back the sharpest images ever taken of Europa's surface. What scientists saw were fractures, chaos terrain, plates of ice that had clearly broken apart and refrozen. This wasn't random damage. It was evidence of motion. Beneath Europa's icy shell lies a global ocean of liquid water, an ocean deeper than all of Earth's oceans combined. And Jupiter is the reason it stays liquid. The same gravitational squeezing that destroys Io gently heats Europa from within, enough to keep water from freezing solid. But here's where it gets even more interesting. Jupiter bombards Europa with intense radiation. That radiation splits molecules on the surface, creating oxygen and other reactive chemicals. Those chemicals don't stay on the surface. They sink. They mix. They may be feeding the ocean below with the ingredients life needs. Jupiter, the monster planet, might be doing something unexpected. It might be creating a habitable environment. That's why NASA launched a new mission to Europa. Juno was the scout. Now comes the explorer. Because if life exists anywhere beyond Earth in our solar system, Europa is one of the best places to look. And without Jupiter, it wouldn't be possible. When we began exploring Jupiter, we thought we understood it. A giant gas planet, a protector, a predictable force. Juno shattered that illusion. Jupiter isn't peaceful. It isn't stable. And it definitely isn't simple. It's a world with no surface and no bottom. A planet that rains toxic hail into itself. A machine built from storms thousands of miles deep. A magnetic dynamo that's cracked and drifting. a cannibal that likely consumed another planet to become what it is. Even its most famous storm is dying. And yet, in all that violence, Jupiter may also be helping create the conditions for life on its moons. Destruction and creation happening at the same time. Juno's mission is almost over. Soon, NASA will intentionally send the spacecraft plunging into Jupiter's clouds, destroying it on purpose to protect moons like Europa from contamination. A quiet ending for a machine that revealed so much chaos. But until that final moment, Juno keeps sending back data. And every transmission tells us the same thing. The universe is far stranger than we imagined. So now the question is yours. Is Jupiter's shattered core proof that it devoured another planet billions of years ago? Or is there another explanation still waiting to be discovered? Let us know what you think, because we're still learning, and Jupiter isn't done surprising us yet.